Another component that has changed dramatically over the years is the bus. We classify buses by two distinctions, data path and speed. And they basically break into two different types of buses. Local buses, which work in synchronization with the CPU and the system clock, an example being a memory bus, and expansion buses, which can work much slower than the CPU, an example being an ISA bus or a PCI bus. So why do we need so many different buses? Well, two reasons. Number one, the speeds of different hardware components evolve at different rates. And number two, a single speed for all components is no longer practical. Why not? Well, let's take a look at what a bus does. What a bus does is, first of all, sends electrical power to all of the components. Second, it carries control signals that coordinate the activity. It also passes memory addresses from one component to the other. And finally, it passes data. There are many different types of buses, and buses have to be very specific for each device. Let's look at some different types of buses. One type of expansion bus is an ISA bus. ISA buses were one of the first buses, and they at first were an 8-bit industry standard. In fact, that's what ISA stands for, is Industry Standard Architecture. They came out originally with the original 8088 PC. They were later revised to have a 16-bit data path, which was like increasing from an 8-lane highway to a 16-lane highway. A bus which you won't see much of anymore is the MCA bus, or Microchannel Architecture. It was a proprietary IBM bus, but since they wanted royalties for the use of this bus, and since it didn't work with a lot of equipment because it was proprietary, it wasn't well received. Another type of bus, the extended ISA, commonly called an ESA bus, is a 32-bit bus that can transfer 4 bytes at a time at a speed of about 20 megahertz. Newer buses include the USB, Universal Serial Bus. Universal Serial Bus is one of the newest technologies around, and is designed so that we can have 127 devices daisy-chained together. The Universal Serial Bus will accept many different types of devices, and it provides both the power and the data for those devices. Another type of bus that is used today is the 1394 Firewire bus. That's an expansion bus which is similar to a USB, but it supports data speeds as high as 1.2 gigabits per second. It's perfect for transferring information off of your camcorder or off of your digital camera. Now let's take a look at some local buses. First of all, the most popular local bus, the PCI bus. PCI stands for Peripheral Component Interface. It has a 30-bit data path, and it runs at 33 megahertz when a system board runs at 66. The devices that are connected to it can run at one speed, while the CPU runs at a different speed. This is a tremendous advantage because it allows tremendous flexibility of this bus. This bus does support plug and play. If you have a PCI bus on a board that supports plug and play, you can be sure that if you get a PCI expansion card, that card will plug and play into the system. In other words, it will find its own resources. For graphics, we have what's called the Accelerated Graphics Port, which is a slot on the system board. It's usually brown, and it looks almost like a PCI slot, but it's a little bit shorter, and it's keyed differently. In other words, the notch is in a different place. only support a single card, but it's designed specifically for a graphics card so that we can get better graphics performance on the PC. So now that we've looked at the evolution of buses, in the next segment we'll take a look at how we can configure the speed and coordinate speed on a system board.